Hello students, today we are going to talk about software paradigms. Let me move to next slide. Okay, here you can see definition of software paradigm. That is actually software paradigm refers to the methods and steps which are taken while designing the software. Okay, it is actually methods and steps which are using for designing softwares. Okay, before moving to the difference between application software and system software, we will see what is actually the computer hardware and some computer software. Okay, I will show you some examples. Need for computer literacy. Okay, why we require computer knowledge. Okay, here you can see some story. That story will give you enough idea. Here, this story I have taken from one website. That website I already mentioned. This is a citation. I cited this website also here. Information is power and computers are amplifiers of information. Okay, information is power and computers are amplifiers of information. When a pregnant woman collapsed into hepatic coma, a surgeon contacted a medical library. He needed immediate information on blood transfusions from the blood banks. Using a computer terminal and retrieval program, a librarian searched more than 500,000 documents in just a few minutes. So, yeah, I hope you know now you understood the importance of computer, right? So, with the computer terminal and some retrieving methods, only he searched particular term in website or internet to get, and he collected millions of documents based on that. Okay, as you know that in Google, if you type anything you can see millions of documents, right? Based on that you may select your wishing paper, right? So here his librarian searched more than 500,000 documents in just few minutes. Necessary information was given to the surgeon and the patient recovered fully. This is actually a story. That story is giving you the importance, showing the importance of computer literacy. Okay, let me move to next slide. Here you can see what are the three main benefits of using computers. Okay, three main benefits of using computers. That is speed, accuracy, capacity to take large amount of work. One is speed. So as we need high speed, right? So in that case, computer we can use computers. We need accuracy, correct accurate accuracy we need to. We need to measure the correct accuracy. Then capacity to take large amount of work. So computer work at a very high speed and are much faster than like humans. The human equivalent to an average computer would be more than 1 million mathematicians working 24 hours a day. Okay, it is they are comparing computer and human. Okay, computer hum, very high speed and are much faster than humans. That example is human equivalent of an average computer would be more than 1 million mathematicians working 24 hours a day. Okay, then accuracy. That is, in addition to being fast, computers are very accurate. If the input and the instructions are accurate, the output will also be accurate. Then capacity to take large amount of work. Unlike humans, computers do not get bored or tired. The monotony of repetitive work for long hours do not affect the computers. Unlike humans, computers do not get bored or tired. The monotony of repetitive work for long hours do not affect the computers. Application of computers. Okay, computers are used in various fields ranging from making cartoon films to space research. Like, in some applications of computers are railway reservation, banking, weather forecasting, medical diagnosis, and space research. Here you can see a computer. This image also I have taken from one website. That website, this link you can see here. Okay, this computer is actually mentioning what are all the devices present here. And you can see computer is a programmable device that stores, retrieves, and process data. We can store something, we can retrieve also. Once it is stored, we can retrieve and we can process it also. We can run anything, right? The term computer was originally given to human, that is human computers, who performed numerical calculations using mathematical calculations such as abacus and slide rule. Working principle of computer. Okay, here you can see I notated some terms. Okay, that is important terms. Just as a human being can be seen as a combination of body and mind, so can a computer. The computer is a two-part system consisting of body, that is hardware, body, that is hardware, then mind, that is software. A combination, a human being can be seen as combination of body and mind. Like we say in the case of computer, the body is hardware and mind is software. A computer, therefore, is a collection of electronic parts, that is body, with a set of instruction controlling it, that is mind. Okay, it is having some electronic parts, but it is having some controlling, the instructions we are using to control it, that is actually mind. Most activities can be described in terms of input process output, that is short term is IPO, that is input process output cycle. This can be illustrated by an example. Okay, let us assume that you are asked to add 1346 and 2936. You first hear two numbers, right? Yes, I heard 1346 and 2936. I need to add, right? And store the numbers in your memory. I already stored in my memory. Your brain adds two numbers. My brain is started to add two numbers. The result is 4281. That also stored in my memory, right? You either speak out the result or write it down depending on requirement. Like, the numbers are input added and the result is output. Here the input 1346 and 2935, the output is 4281. Your ear is an input device, brain is a processing unit, mouth is an output device. A computer system too follows input process output, like input process output cycle. To understand the input process output cycle of a computer, let us take the example of an airline reservation system. A person who wishes to travel by air from Singapore to New York, okay, fills in a reservation request slip. This slip contains relevant data, that is detail of the name, age, place of destination, etc. of the customer. These customer details are the inputs. Okay, here we need input output and we need to store somewhere. So, right, these customer details are the input. The process in this case included examining flight number, date of journey, class requested, and determining whether seats are available as per the reservation details. As a result of this process, the information that either the person gets the reservation or is unable to get the reservation output. As a result of this process, the information that either the person gets the reservation or unable to get the reservation is output. The output may be in the form of ticket, right? Output may be in the form of ticket. Customer details is output. So if seats are available or a message turning down the request. In case the customer is given reservation, his details are stored in the storage device. Okay, what parts are needed for a computer to work? We'll see what are the parts we minimum required to run a computer. A computer does not require all the components. Okay, that we actually mentioned above. That means this one. In this diagram, you can see this is actually mentioning. Okay, here you can see, however, the computer cannot function without having at the very minimum the parts listed below: processor, memory, motherboard, storage device. However, if you had a computer with only minimum parts above, you would be unable to communicate with it. Yeah, until you connected at least one input device, that is keyboard that we are typing. Also, for you to see what is happening, we need to, or like, we can communicate, but we need to see it, right? That is actually output device, monitor. Okay, minimum at least we require one input device and one output device. Then you can see examples of type of computers. This is desktop. This type of computers is called as desktop computer, and this type of is called as laptop, and this is actually notebook, that is netbook, and this is actually hybrid. And that means hybrid means it's monitor is separate and it's keyboard also separate. That is actually hybrid. And tablet and smartphone. That smartphone, okay, this is a tablet, maybe Android or Apple. This is smartphone is Apple. Hardware and software. What is actually hardware and software? That is only we are going to discuss in the upcoming slides. In hardware, computer hardware includes electrical, mechanical, and electronic parts of computer. Any parts that we can see or touch is the hardware. Okay, suppose if you are sitting in a chair, in your uh, chair, and the same time you can see some, you are using some PC, that is computer. If you can touch anything, touch means if you can touch, you can touch hard in keyboard, and you can touch a mouse, right? So that is actually we can call it as hardware. Okay, computer hardware includes system unit, peripheral devices, input devices, output devices, storage devices. Okay, these are all the examples of computer hardware. The term hardware and software are most commonly used terms. A computer needs both hardware and software for its proper functioning. Computer cannot work only with the help of hardware, and only with the help of software it will not work. Both are required for proper functioning. The term hardware refers to the physical devices of a computer system, hence the input, storage, processing, and output devices are called computer hardware. Different kinds of computer hardware, sir, we already seen this, right? The previous. Okay, that is same. Input devices, output devices, remote storage, computer case, data ports. That means input, that is keyboard, whatever we are typing, that is keyboard, and mouse also we are using to click something, right? So that is input, we are giving some kind of input. And output, whatever we are typing, whatever we are giving input, we can see it from monitor, right? That is actually output device. It is giving to see, right? Now we can see it, whatever we are typing, that result we can see through monitor. That is, so we can tell that monitor is a type of output device. And we are going to take a print, so that printer also is an output device. Speaker, what we are talking, we can hear it, like we can hear it, so that is speaker also a output device. Then remote storage, we are using pen drive, right? We are using CD drive, we are using memory card, we are using external hard disk drive. That and all comes under remote storage. And computer case, that means you can see personal computer. Beside personal computer, you can see some cabin, right? Inside that cabin, you can see motherboard. Like that, you can see it, right? That box is called as computer case. Okay, then data ports, maybe USB port is available, serial port is available, parallel port is available. That is actually data ports. Then software, the functioning of the computer is not dependent on hardware alone, that we discussed it. Only with the help of hardware, only with the help of software, it will not get a proper function, right? So what it is required, it requires set of instructions that tells computer what is to be done with the input data. Computer required a set of instructions, then only based on that instruction only it will work. Okay, in computer terminology, this set of instruction is called program. So we all got the definition, right? Program is a set of instruction. Okay, in computer terminology, the set of instruction is called program. Okay, based on that instruction only it will work. So, and one or more programs is called as software. Set of instruction is called program, and one or more programs is called as software. Let us understand hardware and software with an example. An audio cassette, when played, gives you some sound, right? Here, tape recorder and audio cassette can be compared to hardware. The sound which comes from the tape recorder can be compared to software. Software used for both computers may be of different types, some of which are application software and system software. Okay, so we got idea about software and its types. So software is actually one or more programs. Program is set of instructions. Software is divided into two, that is application software and system software. System software, that is software which is using for system activities, that is system software. And software which is mainly used for applications. That means inside system software you may install Adobe Flash, you may install Photoshop, you may install some other application software. That software is collectively called as application software inside system software. In system software means without system software you cannot install application software. That means systems of example of system software is operating system. Operating system. Okay, operating system means suppose I'm using Windows operating system. That means I'm a user, right? I'm a user, and that I'm whatever I am touching, that is hardware. touchable device is hardware. So user, me, I am a user, and touching touchable device is hardware, so that I can tell that operating system is an interface between user and hardware. So operating system is an interface between user and a hardware. User is me, computer hardware is I'm touching, I'm using laptop. This laptop, inside laptop there is a system software available. That system software is operating system. The definition of operating system is interface between me and computer. That means I'm touching. So hardware, computer hardware, the difference, it is the interface between computer user and computer hardware. Operating system is a an interface between computer user and computer hardware. Computers need clear instruction. That and all we already discussed. Set of instruction to carry out these functions. That is program. Group of such programs that are put into computer or operator, and that is called a software. And software are of two different types. That all we discussed. Software is an essential requirement of computer systems. As a car cannot run without fuel, a computer cannot work without software. Car cannot run without fuel. Likewise, computer cannot work without software. Software is intangible, but resides on or is stored is something tangible, such as compact disk and hard disk. System software and application software. We will see what is actually system software and application software, that we already discussed in the previous slide. Okay, we'll see software, application software that is specifically suited for specific application. For example, in the railway and airline reservation, billing, accounting, or software which enables creation and storage document as a terms of, okay, billing software. You may have seen that with some billing software, reservation software, that is actually called as, that is actually application softwares. System software, in the reservation, airline reservation software, the clerk types your name and other details through the keyboard. But how does this go to the system unit? This activity is done by a set of instructions is called operating systems. Okay, so we can tell this operating system is a system software. The operating system manages the various input-output devices of the computer and enables the user to interact with the machine. Operating system only managing I/O devices of the computer, and it enabling the user to interact with the machine. If we require to, if we want to communicate with machine, in that case, that is enabling by operating system. So operating system is the system software. Okay, then it consists of, that is operating system and in language translators. So we will see what are all the language translators found available. Okay, computers can understand in the instructions only when they are written in their own language, that is called as machine language. That means 0 and 1. Okay, suppose I can see one image, but computers can only can see it in binary, that is 0 and 1, or ASCII, like that only computer can see it. So that kind of language is called as machine language. Okay, a program written in the other language should be to do this job. These special programs accept the user programs and check each statement, and if it is grammatically correct, produce the corresponding set of machine code instructions. Language processors are also known as translators. Compiler is a translator. Suppose I reached in China. Okay, if I want to communicate with them, if they don't know about English, if they don't know English language, we have two options. One is we need to study Chinese language, then only we can communicate with each other. Otherwise, we can use some translator. Like we can use some person, he knows both languages, so he will translate, and we can communicate with Chinese people also. So in this case, the same, computer also require translator. Why? Because computer knows only machine languages, either 0 or 1, right? So we need proper communication. So in this case, we require translator, that is actually compiler. Compiler is a translator, and there are many other translators who are available, interpreter, assembler, like that. Some other language translators also available. So in the case of compiler, it is actually converting source code written in the high level language into low level language. Okay. Then compiler, it is a translator system program used to translate high level language into machine language. Then assembler, that is used to translate assembly language into machine language. Interpreter, that is high level language program into machine learning program. And loader, that is a system program used to store machine language program into memory of the computer. Utilities are programs that perform repetitive routine tasks on their own. For example, Bootstrap program, which is permanently stored in the computer, loads the disk operating system when the computer is switched. Device drivers are programs written by the manufacturer of peripheral devices. These programs allow the devices to be connected to a specific make of computer. Computer understands only machine language that we already discussed zeros and ones. There has to be a software which translates the user language into machine language that we already studied, discussed, right? Okay, this and all we discussed already. Okay, I'm going to wind up the class. Okay, students, we'll see in the next class.